Alright guys, we're going to learn how to deal with slant asymptotes now. Remember there were three different criteria for figuring out horizontal asymptotes. If the denominator had a bigger power, it was always at 0. If the numerator and the denominator had equal powers, it was the ratio of the coefficients in front. The third option is a slant asymptote, which occurs when the power in the numerator is greater than the power in the denominator. So what we do to get going on those types of problems is really basically just everything that we've done before, but now instead of a horizontal asymptote, there's a slant asymptote, and we have to long divide in order to figure out what that slant asymptote is. So keep in mind that a slant asymptote looks like, you know, if you have a graph like this, it might look like this. And then if you have a vertical asymptote right there, you may have a graph that looks like this. Okay? So the key is, what is the equation of that line? Because this is a line. What is the equation of that line? Because that's what the slant asymptote is. So what we do is we long divide. That's going to give us a slant asymptote, and then everything else is done pretty much exactly what it was before. There were 6 steps. We simplified. We found the vertical and horizontal asymptote. We found the x-intercepts and y-intercepts. We plotted a few more points. Okay, so start off just like we normally would. We would simplify. And we get x minus 1 over x plus 1. Okay. Step 2 is to find the vertical asymptote, which is obviously going to be at -1. And instead of a horizontal, we have a slant asymptote. So to set it up, to find out what that is, we're going to long divide x squared minus x by x plus 1. So first we'd multiply by x, and then we would end up with a negative 2x. Now this x right here can still go into negative 2x. We would multiply by a negative 2. And in doing so, we have a remainder over here, but it doesn't matter. The remainder does not matter in what we're trying to do. This equation right here, when we divided, that is our slant asymptote. Y equals x minus 2. That's all there is to it. Just long divide. Step 3, plug in 0 for x. In the numerator you get a 0. In the denominator you get a 1. So the y-intercept is 0. Now when we try to figure out what the x-intercepts are, we already factored up here. We put it in simplest form. Remember, the denominator didn't matter for this. So we have 1 at 0 and we have 1 at 1. So x equals 0 and 1. So actually that's steps 3 and 4. 5 was to plot a few more points. Alright, well, let's do this. I need to scroll up so that my graph can appear. And we'll rewrite some things that we had. We knew that we had a vertical asymptote at -1. We had a slant at x minus 2. We had an intercept at y equals 0, an intercept at x equals 0, and 1. So let's start to draw in what we can. 2, 4, 6, 2, 4, 6. Okay, we had a vertical asymptote at -1. And this asymptote right here is just a line with a slope of 1 and a y-intercept of -2. So it looks like that. We also knew that we had a couple of points. It went through 0 and it went through 1. So to be honest with you, we hardly even have to test any points, but we're going to do it just for the sake of practicing. We have test points at, since our vertical asymptote is at -1, we would test at -2 and 0. 0 we already know, it goes through right there. But at -2, we would get 4 plus 2 over a -1, which is a -6. So our next point is going to be right here. And that's good enough to let us know that our graph is going to look like that. So very little difference between these and the other ones that we were working on, just that the asymptote happens to be at a slant now. So let's try a couple more examples. In fact, maybe you want to pause this right now, try it yourself. So go ahead, pause it, give it a try. And let's move this just a little bit. Okay, number 1, simplify. We got x minus 2, x plus 1, all over x minus 1. We have vertical asymptote at 1, and we have a slant. So we have to take x squared minus x minus 2 and divide that by x minus 1. We multiply by a negative x to get, I'm sorry, we multiply by x to get x squared minus x, and then you have a -2 down there, and x cannot multiply by anything to get into 2. So our slant asymptote is just x. Well, that's easy enough. It's a little too wide. Slant asymptote like that. And we also have a vertical asymptote at 1. Now let's find our zeros. You plug 0 in for x, and you end up with a -2 on top and a -1 on bottom. So the y-intercept is 2 right here. You set the equation equal to 0, and based on what we have up here, x equals -1 and 2. So x is equal to -1 and 2. Again, just for the sake of practice, we are going to test 0 and 2. Oh heck, we don't even need to. 0's right there and 2's right there. So we have enough for our graph. Looks just like that. One last example. I'm going to work backwards this time. In other words, the stuff's going to be on the bottom. Okay, so simplify. Doesn't look like the top can be simplified at all. So 1 is a scratch. There's nothing for us to do. 2, vertical asymptote at 0. And there will be a slant. 3x squared plus 1 divided by x. We have 3x and a remainder of 1. So our slant is at y is equal to 3x. I hope you pause this and try it yourself before you let me do this for you. 3, if you plug 0 in for x, you got a problem. Because then you have a 0 in the denominator. So no y-intercept. 4, set the numerator equal to 0. 3x squared plus 1 equals 0. And you should recognize that if you were to do that, you would end up with imaginary numbers. So there is no x-intercept either. 5, where should we test? Well, if the vertical asymptote is at 0, we should test -1 and +1. When I plug in a -1, I end up with a 3 plus 1 over -1, which is -4. When I plug in a 1, I end up with 3 plus 1 over +1, which is a +4. So let's put some stuff together here. A vertical asymptote at 0. Horizontal at 3x, which means it's going to hit that point, and that point, and that point, so it looks like this. Okay, we have a couple of, we have no intercepts, but we do have some points, but pay attention to this. Since we don't have any intercepts, we know that it doesn't cross this line, and obviously it doesn't cross that line. Furthermore, we have two possibilities for this graph. It either looks like this, in which case it crosses the x-axis, which we know doesn't happen, or it's going to look like this. And notice in those cases it doesn't cross the y-axis or the x-axis. So that's where it's going to be. We have two test points, -1, -4 right there, and +1, +4 right there. I missed it a little bit, but that's alright. We know what it looked like. And of course I would be remiss if I didn't number my axes. That would be uncivilized. Anyways, there's our examples for slant asymptotes. I will see you in class.